Connected Components Workbench, Micro800 Controller Programming. Garage Door Exercise Part 5. We had a couple pages in the manual at the end of the garage door project that we converted the OTEs to latch and unlatch, or if you like direct coils, to set and reset coils. The next section of the lab was us doing modifications to the garage door opener logic using latch and unlatch. And the only modifications that we did in the manual were to the light function, the functions or the logic that control the light. I'm going to do a little bit more than that just for fun. If I wanted to narrow the logic, meaning make it fit better on the screen. Once you've been in this business for a while, you'll find that you have rungs of logic that tend to be difficult to read and analyze because they're too wide for the screen, and they do something called wraparound. They actually form a serpentine pattern so you can see all of them on the screen, but it does make it hard to analyze the logic, especially in cases where you have branch arounds, and the branch arounds wrap around, including the main rung. First thing I'm going to do here, and this is a big deviation from the manual, is I'm going to make this rung narrower, and I'm going to do that by right-click, copy. I don't know why the computer's so slow. Right-click, paste. So now I have two rungs that look like that. The first thing I'm going to do is I'm going to delete this instruction, and I'm going to replace it with an output energize. I'm going to assign a bit in memory to represent these 5 conditions. I'm going to replace that with enable timer, because that's what these 5 conditions do. Enter. That's not a tag yet. Now right click on it, variable selector. See, it's all filled in up here, and I want to make it local scope sequence. So I'll say OK. I'm going to go down here and I'm going to eliminate all but one, and I'm going to reassign this to read enable timer. So now you see I have these 5 conditions that enable the timer. Now that's exactly what they did before. I've not changed anything other than I put these 5 conditions, their collective states, into a bit that I named enable timer. Then I'm using that bit to enable the timer. Nothing has changed here logically as far as the timer is concerned, but now my logic is more narrow. If I close this up or I open up this window so I can see everything, I don't have the wraparound and I don't have logic shifting off of the screen. And we could actually close it up more than that, but I just wanted to show you typically what I do if rungs get too wide. I may take sections of them and collectively have them turn on another bit that represents their collective state, and then use that in the actual rung. The one thing that we did in the lab was in this instruction right here, instead of using the timer not done, or the not Q, whatever you want to call this bit, instead of using that to unseal, see, we have output 2 sealing in output 2. So first I'm going to change this to a different instruction, and I don't see a way to just right click on it. I don't see a way to change that. What I have to do is delete this instruction. Then I can go up here and grab a set. See, now I can drop it in there. I can go here under user global variables and pick output 2, or I could have just typed it in. I'm already here, so I'll select it and say OK. I don't need this anymore, and I don't need this anymore. Those 2 instructions, one of them sealed in the rung and the other interrupted that seal in to reset it. Now I have a situation where any one of these 4 conditions can set that bit, so that would be latch. I'm going to use the timer when the Q to unlatch. Again, I go back to user variables, and that's specifically what we did in the manual, and that's all we did. However, I'm going to go a little bit further. I'm going to go up here and look at this logic, and the reason that my copy here says both push buttons pressed even though we've already changed it is because remember when I was doing the mess with the TON and I kept going back and opening up the original logic and then trying different methods of putting in that timer because the tags weren't showing up in the database. Since then, I found out if you click on that asterisk, and what that has to do with refresh, I have no idea, but if it works, it works. We'll go with that. So first we want to change this to, if I clicked and typed it in, I would be creating a new tag. Instead, I want to edit the existing tag. I can go here, type in safety interrupts, and notice when I edit an existing tag, it changes every place that that tag is used. If I created a new tag, then I would have to go and reassign these instructions to read the new tag. The next thing I want to do is I want to change this to a latch or a set. To do that, we already know we can't drag it down. See, it won't let you drag it down and drop it. In the other PLCs, you can do that. And the reason I like to do that is that way I can drag over the tag name to the new instruction. Well, we already know you can't drag that tag name over to another instruction, so I guess that makes that a moot point. I will delete this instruction and put in a set and just select it, safety interrupts, which means I don't need this seal in anymore, and I don't use the stop push button to eliminate the seal in. That eliminates this branch. Now we have two conditions that will set the bit safety interrupts. If the up and the down push button are pressed simultaneously, even for a split second, or if the safety photo eye is blocked, it detects an obstacle under the garage door, the path, while the motor is energized in the down direction, it sets this, which means we have to reset this. And what we used before to undo the condition was the stop push button. So we're going to add a new rung, and we're going to use the stop push button push. I'm just going to type in IN00 and see if I get away with that. The stop push button is, or if it's pushed. If the stop push button is pushed, then we want to reset safety interrupts. So we simply removed the seal in part of this logic and the way to clear the seal in out of this rung, converted it to a set, and we put the stop push button in a separate rung that resets this. So this logic will work exactly the same as the other. The difference is that now it's in two rungs, and there really is no way to put this into one rung. Off the top of my head, I can't imagine it. And the problem is these two rungs could get separated. Now we only have less than half a dozen rungs in our logic. But let's say you had 200 or 300 rungs in your logic, and you had these two rungs that are interrelated or interdependent. They could get separated, and then you would have to go through some search and find the logic that unlatches the safety interrupts. Now you can use the terms reset and set if you want. Those are perfectly legitimate, but I'm going to refer to the set as latch and the reset as unlatch. In terms of computerese, set and reset are more conventional. In terms of relay ladder logic diagrams, latch and unlatch are more conventional. Let's look at this logic. We want to set the motor up and set the motor down in certain conditions. This will require a little bit more thought, which means that we're no longer going to seal in either one. I'm doing this on the fly. I didn't do this in advance and then back up and show you what I did. So I'm showing you my thought process. We don't need the stop push button. What we need is the up push button and the down push button. Now we're going to have to put these conditions back in somewhere else. But for right now, I'm going to replace this OTE with a set and replace this OTE with a set. So now if you push the up push button, it sets this. If you push the down push button, it sets this. If they push the up button and the down button simultaneously, that sets the safety interrupt. So we're going to leave this alone. Now I'm going to go down here and I'm going to add another rung, because remember we pulled out the logic that undoes the seal in. So now we have to add it back in. The first one I'm going to put in is this right here. So Control C, Control V. I'm just trying this as I go. I'm applying basic practices from the convention of all other programming packages for PLCs. A lot of it resembles word processor of cut and paste. I copied that instruction down here, and I'll put what I want down at the end here. Okay, and I want to reset or unlatch output 0. So I'll just put that in there, and I'm going to put a branch around, because I also, if I hit the stop push button, want to clear output 1. So I bring down a reset for output 1. If you hit the stop push button, remember the stop push button is a normally closed contact. So if it's not pushed, it's on, and then that would mean this is false. When this is false, you're not going to reset up and down. Keep in mind, the logic doesn't know the state of any bits in memory. However, the logic can be written in such a way that based on the states of bits in memory, it can take action. Meaning, this logic doesn't know that the up or the down push button's pushed. It doesn't know if the motor up or motor down starter coils are energized. It doesn't know anything. However, it reads this and tells that you're on. It reads this and tells this it's on. In other words, if this bit is on, true if on, it sets that bit. If this bit is, if it was an OTE, but because we're using set and reset, where the OTE had a true and a false execution, these instructions only have a true execution. So if this is true, it sets that to 1. If this is false, it does nothing. If this is true, it sets this to 1. If it's false, it does nothing. Same thing down here. If this is true, then it sets both of these to 0. So now we have the ability to pick the up and the down and turn on up or down. However, we're back to the condition we had before where they could turn on both of these. We do have to have logic that prevents setting both bits. So here's a thought. Do we change the logic so if they push the opposite direction that it stops and then they have to push it in the right direction? In other words, if it's going up and they push down, do we just let it reverse, or do we want that to make it stop entirely and then they have to push the down again? You might want to argue that the door has some inertia, and if you hit the opposite direction, that it's not just overcoming the static inertia, but it's overcoming additional inertia of the fact the door is going in the opposite direction. Well, we won't get that complicated. We'll just put those instructions back in here that does not allow you to set this bit if this bit is already set. So we grab a true if off, and we want to make this output 1. So we put that instruction back in there. This is just the thought process of doing this. If the motor is being told to go down, you can't push the up push button to reverse it. So we're going to make you stop it. Here, we're going to put in the same thing except for the opposite direction. Now, you can't reverse the direction while the garage door is in motion. You would have to stop it first, and then when you push the stop button, this will go true. This will reset both of these. Now, they're not both set, but it doesn't matter. It just tells both of them you're off. One of them's already off because you can't turn both of them on here. You can't now that we put this in here. The other condition that we had was that you can't tell the motor to go up if it's already all the way up. Although I took those instructions out and now I'm putting them right back in, I'm going through the thought process of rethinking. Rather than throwing a band-aid at existing logic, I'm actually rethinking the logic as I'm doing this. And this is what I would do on the shop floor on a customer's machine. I'm not going to erase all their logic, but if I'm going to make some changes, I'm going to rethink the whole original process of why I want the logic the way it is. What we need to add here is the logic that does not allow you to run it up if it's already up. And that was if the up limit switch was on, because remember, it's a normally closed so it's fail-safe. In other words, if it's all the way up, then it is holding that, it's tripped that switch and it's holding it closed. Grab a true if on and put it in both locations. Input 5 right here, which I believe is input 4. So now we got this logic back in here. And this gives us everything that we had before. Either one of these is an interrupt. whether it's both push buttons simultaneously pressed or if you're on your way down and you break the photo eye. And then we use the stop push button if you press it, because remember this is a normally closed push button. When it's not pushed and this is on, this would be false, so this doesn't execute. So if you push the button, then this goes true because input 0 went off. That resets and eliminates this bit. Now if you're still holding down both push buttons, then this will set just as fast as you reset it. Here we're saying if you push the up push button and you're not already up and you're not telling the motor to go down, then tell the motor to go up, and the same thing down here. If you want to reverse direction, you have to stop the door and then press the button to go in the other direction. So we made this logic a little bit different. Now I'm going to save it, download it, and go online with it. Download it online. First thing I want to do is check the very first thing we did was we changed the light control from OTEs to set reset or latch unlatch. I'm going to bump any one of the 4 conditions over there, and to do that I'll just hit the stop push button because any one of these going true in rung 5 will do the trick. So I'm going to push the stop push button. Now I'm going to hold it down. Notice that when I hold it down that the timer is not timing. That's because the way the program's written, it has to see the stop push button, input 00. It has to see that input go on, which means not press. So watch when I release. You see in rung 5, true if off is true, it sets the light on. So the light's on right now. Rung 6 will enable the timer once I let go. See, I let go, the timer's enabled, and after 15 seconds, then Q, the done bit, will execute the reset unlatch instruction of output 02, as we know through the buffering turns on that light. So we know this logic that was OTEs is now latch unlatch logic, set reset logic. It functions. So now let's go up and look at the upper logic that we changed after. Now let's do the safety interrupts first. I'm going to push the up and the down push button. And I can see now that I don't have the safety interrupts included in the logic down below in rung 3. I forgot to put that in. I'm going to pause, make that change, and come back. I have the safety interrupts, that bit that's turned on by either both up and down buttons pushed, or if the safety photo eye is tripped when the motor is powered down, and we add that bit to reset motor up and motor down. If either one of these 2 conditions happens, then it will reset both these bits, meaning it will turn off output 0 and output 1. It really doesn't matter which one's on, it just turns them both off. One of them's already off, of course. Both of them end off. However, that does not reset the safety interrupts. You still have to use the stop push button to do that, which is exactly what we want. Let's demonstrate that. I don't have to mention, but right now neither one of these motors is turned on. In order to run it up or down, one or both of these have to be on, meaning that if the garage door is all the way up, which it is right now because you can't tell it to go up because this is false. I'm going to tell it to go down, which would be input 2. It's on its way down, and if I do either one of these up here, I'll just do this safety photo eye input 3. I bumped it, it set the safety interrupt bit, and that reset both of those motor up and motor down bit. And that's about all there was for this lab.